Okay, welcome to this lesson on changing the shape of a quadratic equation or quadratics. Um, Up until this point, every quadratic has had the same basic shape, which we use the step values to generate, which is like basically, I'll get my pen turned on here. 1 over, so if this was the origin or the vertex. We start at a vertex, we go 1 over, 1 up, 1 over 3 up, 1 over 5 up, and so forth, and that creates a shape of the quadratic. Okay, so we're going to go to show you in this lesson how that shape can change, because not all quadratics have this exact same shape. Okay, but it is the standard basis of which we use to create the shape of all quadratics. So there's some changes, but there's also some commonality or commonness. Okay, so what's easiest for me to do is to actually uh, gr- uh, graph y equals x squared. And so y equals x squared has a vertex of 0, 0. This was the very first quadratic we graphed. There's no change to the y and there's no change to the x in the vertex. So therefore 0, 0 is what it'll be. In fact, I'm going to keep all my graphs today, at least in the first part of this lesson, at 0, 0, just to make things simpler. So if we're going to graph it, first thing we're going to do is we're going to label our graph x and y. This is something you should be becoming very familiar with me doing all the time right off the bat. And then we're going to plot the vertex 0, 0 right here, okay? And this is pretty common. And then we're going to just use our standard step values to create our graph, okay? Oops, so, sorry, I just made my graph a little bit too small there. I'm just going to pop it up, pop it down a bit. Sometimes my palm of my hand hits a button, doesn't like it. So anyway, 1 over, 1 up is our standard step value. And then 1 over and 3 up, 1, 2, 3. And then 1 over and 5 up, 1, 2, 3, 4, 5. And then 1 over and 1, 2, 3, 4, 5, 6, 7 takes me right to the top. Okay, so 1 over, 1 up, 1 over 3 up, 1 over 5 up, 1 over 7. And of course, we had room, we'd do 9, 11, and so forth, but we won't go that far. In fact, I'm already going way further than I often normally do. Then I do the same thing on the other side, 1 over, 1 up, 1 over 3 up, 1 over 5 up. And you notice I don't count them out this time because I can see the point here. So I know that I'm going to go up to the same point there, which is kind of nice. It makes life easier for me, okay? And then 1 over and all the way to the top will take me to 7, okay? And now I can graph this line quite nicely. I've got all my points and off I go. I just follow through each of those points and try to make it as much of a U as possible. Try to keep my hands steady flowing the whole time, and that makes it easiest for me. Those people who are artists and take art class, they'll be better at it than those of us who are a bit more clumsy. Okay, and I can label this graph y equals x squared. That is our standard most basic parabola that we can draw, okay? Now, sometimes I'll write the step values here, which you guys know are 1, 3, 5, dot, 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 as usually 3 of them is enough to see the pattern, and away we go. Now, for the next graph, again, the vertex is going to be 0, 0, and I always write that down. I always state that, okay? So this time it's y equals 2x squared. And you'll notice that we've added this number out in front that multiplies against the x squared. Well, what that does is it multiplies against our standard step values over here. So now the step values here are not going to be 1, 3, and 5. They're going to be 1 times whatever this number is. So in this case, 1 times 2, which is going to be 2. And then it's 3 times 2, 6. And then it's going to be 5 times 2, 10. And if we had 7 times 2, 14, and so forth, dot, dot, dot. And it would get pretty long, to be honest. We could continue on up, but I don't think we'll be able to graph steps of 14 even. Now, let me show you how this actually works in real life. So what we do is we always go over 1. Okay, sorry, I'm making the graph just a little bit smaller. I'm going to try to increase the size a little bit here, see if that works. There we go. Okay, so again, I'm going to start at my vertex of 0, 0, 1 over, and not 1 up, but 2 up. So this time I'm creating a point there. 1 over, and not 3 up, but 6. My step value now is 6. So it's 1, 2, 3, 4, 5, 6. And I come all the way to this point. And the next one would be 1 over and 10 up, if I can fit it in. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. Oh, it doesn't fit, but let's just pretend there's some more spots. It would go way up here. This big dot up here I'll make would go way up there, okay, above the grid. Normally I don't do that, but we'll just pretend for today, okay? Then we have over here on the same thing on the other side, 1 over, 2 up, and then 1 over and 6 up again, and I count up to 6 spaces in our 6 spots up to here, and then it's 1 over and 10 up again, and it's going to go beyond all the way up here, and that creates a new shape to my parabola. It is not the same as y equals x squared, it's y equals 2x squared, and I can draw it, and it goes like this, and comes down and floats around, a nice U shape if I can. It's harder as it looks really quite pointy, and that now represents y equals 2x squared. And what we say is this graph now is steeper, okay? It's not the same as the standard y equals x squared. It's steeper, it's inside it, and we call that a steeper parabola, okay? Now we're going to do one also that's 1/2, and it works in the same basic thing. Let me do my point here. I'll write it down. Y equals 1/2 x squared. My vertex is again 0, 0, because there's no push or change, no value of that are getting squared. There's nothing added on in the end for the y change, so it's just 0, 0. I'm going to just do a little cleanup here. Sorry. My palm sometimes touches the screen and then it thinks it's the pen and then it writes for me. Now, my step values for this one, okay, so my SV are going to be 1/2 times 1. Well, that is 1/2. Then it's 1/2 times 3. And I always say kids, well, what's half of 3? If you had $3, what's half of it? Well, it's $1.50 or $1.50. And you can write it as 1.5 or you can write it as 1.5. For some reason, I just like to write it as 1.5. I don't know. Math people like to stick to fractions. They're just silly that way, okay? But it would make no difference if you wrote it as 1.5, okay? Then the next one is going to be half times 5. Well, what's half times 5? Well, it's 2.5. And are you starting to see a pattern here? Half, 1.5, 2.5. What do you think the next one will be? Well, if you're guessing 3.5, you did a good guess. And the next one would actually be 4.5, 5.5, 6.5, 7.5, and so forth. The steps would just keep increasing by a value of 1 each time, okay? Over here, they were increasing by a value of 2, and now here, they're just increasing by a value of 1. And let's see how this graphs out, okay? So we graph 1 over and 1/2 up, okay? And that marks halfway up the point, okay? It's a little confusing, so I'm just trying to keep that dot a little bit more prevalent there if it doesn't disappear on me. So then 1 over again and up 1.5. So that half is there, and then 1 more makes 1.5 up. Okay, and then it's 1 over and 2.5 up. So 1, 2.5 space. That's why I like using just halves. I mean, people understand half a space, right? Like it's not that difficult. And then it's 1 over and 3.5 up. That's a half plus 3 more. 1, 2, 3. Brings me back to this dot here, point intersection. And then it's 1 over and 4.5 up. 1, 2, 3, 4.5 up. Okay, let me double check. Count that right. 1, 2, 3, 4. I did. And it just disappeared on me, and I'm going to darken it up here. There we go. Some of these dots, they don't like to do just little points. They like to draw lines with these pens better. Same thing on the other side, 1/2, 1 over, half up, okay? And then 1 over, up 1.5, 1 over, up 2.5, 1 over, and up 3.5, and that brings me to here, and 1 over and up 4.5, 1, 2, 3, 4.5, right there. Okay, and now you can see here I have a series of points that are kind of to the outside of the standard parabola, and I can draw that in. Whoops, kind of got off track there, and then come back around and here. And again, I put my arrows on my parabola. Always remember my arrows, and I can label this. This is y equals 1/2 x squared. What's really neat is that essentially what I've done is I've created a flatter parabola. And so the way we do that is this number out in front. They assign this number the letter A, okay? So they call it A. So before we had P and Q, now we have an A. And to be honest, some textbooks use H and K instead of P and Q. So it's not a standard 100% guaranteed thing, okay? I'm going to move down and I'm going to show you another way that we can modify our parabola. And this is one that sometimes students have already seen or pointed out to me. Well, can we draw it upside down? And you bet we can. We can draw it right upside down. And so just gonna go in here, draw this like that, and get myself set up. You guys have the full sheet of paper in front of you, so it's a little easier for you than it is for me. So once again, all of these two, I'm going to do two graphs here. They're going to be both vertexes of 0, 0. Okay, so I'll get my pen turned on, and my vertex is 0, 0 in both cases again. Okay. There's no change, there's no shifting, and we're going to look at that in a minute, okay? In the next example on the next page, we'll look at that. So label my graph. X is going to be here, Y is going to be here, and you'll notice that this time I've conveniently created my axis so that I have more space down below because guess what? We're going to be upside down. And this is not too shocking, but in this particular case, think of minus x squared as being like minus 1 x squared. So we take our standard value, step values, and we multiply them now by minus 1. What are our standard step values? Just write them over here, 1, 3, 5, 7, dot, dot, dot. Okay, so my step values over here are going to be minus 1 times 1, which is minus 1. Minus 1 times 3, minus 3. Minus 1 times 5, minus 5, and I think you're getting the idea. It's going to be minus 7. So we can graph this now, starting at our vertex of 0, 0. It's always important to get your vertex. Now it's 1 over, and the step value is minus 1. Well, that means we go down 1. Minus just means we're going to go down. So minus 1. So 1 over, down 1, 2, 3. 1 over, down 1, 2, 3, 4, 5. And 1 over and down 1, 2, 3, 4, 5, 6, 7. And there is our points on the one side, and we can do the points on the other side just as well. 1 over, down 1 here, 1 over, down 3, 1 over, down 5, and 1 over, down 7. And you notice I can plot those a lot quicker because I always make them like right across from the other one. And so it's just a matter of moving over and looking across. I don't have to count it out again each time because I can just see it from the graph. Now I can graph my line and I can go like this. If I get through all my points here. And like that. And not bad for a non-artist, I figure. Anyway, so that is y equals minus x squared. So it's the exact same thing as x squared. It's just flipped right upside down. It's just literally, instead of it being a U shape, it now kind of looks more like an N. Okay? And if we do minus 1/2, it's the same thing. Remember the step values for 1/2 were going to be 1/2, 1.5. Well, now they're minus 1/2. And doesn't like something here. I'm just going to just move my mouse into a different position. Sorry. And bring my pen back on. Minus 1/2, minus 1.5, minus 2.5, minus 3.5, and so forth. I think you get the idea. And so again, I start at 0, 0, over 1, down 1/2, over 1, down 1.5, over 1, down 2.5. And you can start to see here, over 1, down 3.5, which brings me to this, and then over 1 and down 4.5. 1, 2, 3, 4.5. And so I kind of get those points plotted there. Okay, I'm cheating a tiny bit, just keeping away from the other graph, but you can see that they're a little further to the outside. Again, making the parabola a little bit flatter. And then I can plot them on the other side as well. Over 1 and down. Pen's turned off, sorry. Over 1, down 1/2. Over 1, down 1.5. Over 1, down 2.5. Over 1 and down 3.5. So 1/2, 1, 2, 3, and then finally over 1 and down 4.5. 1, 2, 3, 4.5. Should be lined up with the other side. Notice always these points are directly across from each other, and now I can graph this shape here like that. I lifted my pen, so it never looks as good when you lift your pen. And then we'll label that y equals minus 1/2 x squared. Okay, now we can put all this together with the shifting of the vertex and the changing of the shape. We can do graphs like this together. So I have a couple of them on the next page. So let's go to these and see if we can do this, okay? So first thing I'm going to do is, before I even graph anything, I'm just going to state the vertex and the step values for each one, okay? Make life real easy. Well, by the way, I noticed something here. I have my P and my Q backwards. And I don't know why I did this, but this should be P here, and this should be Q here. And if that's wrong on your sheet, please fix it. Hopefully for future sheets that I hand out, I don't have it incorrect. But if you notice it on yours is wrong, then please switch it. I'm not really that concerned about this equation. Sometimes kids get really confused by it. It's really, you just need to know how to extract the information from these equations. So remember, to get our vertex, this gives me my x value right here, but I change the sign. Okay, so instead of -1, it becomes +1. Okay, my y value is just this value here, and I don't change the sign. Lots of students get this mixed up. Change here, don't change there. So my vertex is 1, 4. Over here, same thing. Vertex is -2, because this changes sign, and -6. That one does not change sign. Let's get my minus in there a little better. And there's my two vertexes for the two equations that I'm going to do. I could go plot those right away, but I'm going to kind of cheat here, and I'm going to do my step values for both of them, okay? Now, this value, the number out front, it helps me determine my step value. So that's for my step value here and my step value here. And this number multiplies by the standard step value, which is 1, 3, 5, 7, okay? And 9, 11, 13, 15 if you want to just keep going, okay? So my step value on this equation is going to be 1/2, because 1/2 times 1 is 1/2. Then it's going to be 1/2 times 3, which is 1.5. Then it's going to be 1/2 times 5, which is 2.5. And then it's going to be 1/2 times 7, which is 3.5. And we can keep going, 4.5, 5.5, and so forth. Okay, I'm not going to write too many. That's plenty of numbers there. Okay, my step values here equals -2. Oh, sorry, sorry, my step values here are 2, not minus 2, the number in front times each of these. So this one will be 2 times 1, which is 2. My pen turned off. I apologize. Turn it back on. 2. 2 times 1 is 2. 2 times 3 is 6. 2 times 5 is 10, and 2 times 7 would be 14, and that is more than enough. Of course, we can add more numbers if we want. We can see the pattern. This one's increasing by 4 each time, so this will be 18, and then it would go to 22. This one's increasing by 1 each time, so it would be 4.5, 5.5, and etc. Now, I'm ready to graph these, and I have to just scroll mine down so I can see my graph, okay? And whoa, stop there. So the first one is point, let's do always label my grid. I always get ahead of myself. Label my grid. Don't be stupid, Mr. Lou. Trust me, I am at times. And then 1 over and 4 up. 1, 2, 3, 4. And this is my vertex. Now I can label the vertex, but I do find sometimes if I label the vertex, it kind of clutters my graph, especially if I'm going to do multiple graphs on one, or parabolas on one grid. So in this case, 1 over up a half. That's my step value. I'm using the step value right here. Okay, 1 over up 1.5, and I'm just kind of gently plotting these points in. Okay, 1 over up 2.5. 1 over up 3.5. There's a half, 1, 2, 3. And if I go one more, it's going to go off the grid. So I'll stop there. Then I go 1 over up a half. Okay. 1 over up 1.5. 1 over up 2.5. And that takes me to here. And then 1 over and up 3.5. And that takes me to this point. Okay. There. And now I can plot or draw this line, okay? I just kind of draw it in, and remember, try not to make it into a V, try to keep it a U. And there we go. Not bad. I'm pretty happy with that. And I can label it y equals 1/2 x minus 1, is it? Squared plus 4. Okay. And let me just double check. Did I do that right? I can't see my, yes, that's correct. X minus 1/2 plus 4. Now I'm going to go down and graph my other grid, which is 2 times 2 plus 2 times x plus 2 squared minus 6, okay? And I can still see my data there just enough to be able to do this. It works okay. So in this particular case, my vertex is minus 2, minus 6. So x is minus 2, 1, 2. Y is minus 6, 1, 2, 3, 4, 5, 6. There's my vertex right there. And I can label this vertex. I think I'll do that. Minus 2, minus 6. There we go. Okay, and then I have to plot my points. So it's or plot my points using my step values. 1 over 2 up. Okay, 1 over how many? 6. That's the next number in my step value list, right? 1, 2, 3, 4, 5, 6. And then 1 over and 10 up. Oh, can I make this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There it is. I made it in there. 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is correct, okay? Double check my counting there. Then I do the same thing on the other side. 1 over, 2 up. And again, like I was saying before, I don't have to count again. I just go 1 over and I go across from this one. I just make sure I'm 1 over. So I'm 1 over from this and then go up and parallel to that. 1 over and all the way up here will be the 10. And now I have a symmetrical shape that I can create here. Now it's a matter of drawing this line. I say graphing, but it's really drawing. It's artwork almost, right? And we come all the way up and across like this, okay? And I can label this as y equals 2 bracket x plus 2 squared minus 6. And I now have that graph labeled and drawn all together, okay? Now, all they do, they love to talk about this thing called y equals ax minus p squared plus q, okay? And all they're doing is saying, this is your a value, this is your p value, and your p value changes signs. So to do that, they say if it's minus, then it's positive, and it's positive, it's minus. And then your q value is just simply there, and it does not change signs, okay? So if it was plus q, it's plus q. If it's minus q, it's minus q. All right, and p and q give me my vertex. A gives me my step value or change in step value from the standard step value. And some textbooks, some people like to teach using that or explaining it that way. It really doesn't matter to me. All right, that's the end of this lesson on changing the shape. Please give a shot at graphing. There's lots and lots of different parabolas that you can practice graphing. I think I gave you 8 to work on. That should be enough to kind of get you started. And if you have any questions, just fire them my way and we'll help you out the best we can.